Hi guys, we're looking at question 1a, power of powers. All right, so we've got x to the 7th times x squared, and we want to simplify in, it says radical form, it's supposed to say in exponents. We want to simplify this. Whenever we're simplifying with exponents, our goal is to condense. We want to combine stuff, make it smaller somehow. So our answer is going to be, the base is going to stay the same, and we just need to figure out what that exponent is going to be. So different ways we could do this. We could do expanded form and write out a whole bunch of x's and count up how many x's there are. Or we can use the power of powers law of exponents, which tells us if we have the same base, we're in different exponents, we're multiplying with the same base, we're going to add the exponents, right? So that was, for our notes, it was a to the power of m times a to the power of n equals a to the power of m plus n. So what we're doing is we're taking those exponents and we're just going to add them. All right, straightforward. Same thing here. Base is x, but now instead of 7 and 2, we're going to add them together. 7 plus 2, 7, 8, 9, and box. That would be our final answer. So whatever we're multiplying with the same base, what is our shortcut? We're going to add those exponents. That's going to give us our answer a little quicker. All right, let me jump to our next problem. This is part B. So all of the part B's I'm going to skip in this video because you've got a linked linked video for help. And you also have the answer key at the very bottom. So all the ones that have a B at the very bottom, you'll be able to check your work. So using this video is going to be just for the A's. All right, question number 2, which would be A. Quotient rule. Same idea, same idea as product rule. Quotient, though, means dividing. We've got 2 to the 6th power divided by 2 to the 4th power. And let's revisit what our quotient rule tells us. So if we've got some base a to the power of something, m, divided by same base a, or whatever it is, same base, to the power of some other exponent, what do? We're going to take the base, and now our cheat, our hack, trick is to subtract the exponents. You might recall from your Engagely notes, but quotient rule, this is when the order matters. So order matters. Order is very important for quotient rule. It always has to be the numerator minus the denominator's exponent. Very important. All right, and we can check. So our base in this case is 2. We're doing 6 numerator minus denominator, so 6 minus 4. That will leave us with 2 squared. I left a lot of room here because I wanted to show you how we would get the same answer if we were expanding it out. So we'd write 2 6 times, so 1, 2, 3, 4, 5, 6. Those are all being multiplied. 1, 2, 3, 4, 5, 6, and then 4 2's, 1, 2, 3, 4. And we can cancel, and we'll see that there are 2 2's left in the numerator. So 2 squared. So anytime we see we are dividing and we have the same base, our trick, law of exponent, tells us we can just subtract, right? Because that was a lot quicker to just subtract versus expanded form, right? We're kind of shifting away from expanded form. Just wanted to show you, you do get the same answer. It's just a little bit more work when you use expanded form. All right. This is B, so you'll do this on your own. This is a check-in for 3.2. Here we go. Question 3, it should say A. I'll have to fix that later. All right. Simplify the following radical using, it says either of the 2 methods. Ignore that. We only learned 1 method, so I'm going to change that too. Be sure to show all work and steps. All right, so we've got rad 84, radical 84. And thinking back to what we've learned so far, when we have a radical and we're simplifying, we're going to use, remember, the factor tree. So I know that it said 2 methods. The only one we learned was factor tree. The factor tree method. So I'm going to cross out 2. That's the only method we learned was factor tree. All right, so we're going to go ahead and start our little tree. 84, we do have a calculator, and you'll have one on your exam as well. And let's check. 84 maybe divided by 4. Ooh, okay, that worked. So 4 and 21. And remember, factor tree, our goal is to get all of the prime factors, Just from here, you might have noticed, ding, 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 celebrity sighting. 4 is a perfect square. If you didn't catch that, it is also composite. We can keep going. Remember, we always want to circle our prime numbers. 21 is 3 times 7, and we'll go ahead and circle those. So this is, again, for your TGA, this is what I'm expecting to see is all of your work, your factor tree, we're circling in our prime factors. All right, next step that we learned in class is we're going to go ahead and rewrite the radical sign, and we're going to list out all of those prime factors, listing them all out. And let me just double check before we do that all those prime factors do give us 84, right? It's always good to check our work. So 2 times 2 times 3 times 7, yep, 84. I highly recommend checking on your exam too. Just takes just a quick second, and then, right, because if we had something wrong, we have to go back and double check. Okay, maybe 3 times 7 wasn't the factors of 21. So it's always good to kind of go check along the way as you go, just to make sure we're doing good. Okay. So we're going to list them all out, least to greatest. So 2 2s, 1 3, and 1 7. And this is just a plain old radical sign. So remember, when we have a plain old radical, the index is not given. There's no index, right? The index is like that little waiter, like holding a number. There's no number there. So the index is going to be 2. If it's a plain old radical, index is 2. What does that index tell us? Remember, the index is telling us how many groups of the same number we're looking for. Index here is 2. So 2 we're looking for in this list of prime factors. Did we copy and paste a number? Is there 2 of the same number copied and pasted? So we're scanning. We've got 2, 2, 3, and 7. We're like, oh my, 2 2s, right? This guy was copied and pasted. There are 2 of the same number here. So what happens? One of them is they're going to be factored. One is canceled, and the other is factored. It leaves the radical. It's like it's leaving jail. So we've got 2 rad. 3 times 7 is 21. It stays in the radical because unfortunately it did not have a partner, right? There was nobody could partner up with to be factored out. So it stays in the radical, and that looks like it's it. That's all we need to do. We are not plugging that in the calculator, rad 21. We're leaving it. This is how we're simplifying. Showing our work with our factor tree, listing them out, showing that something's being canceled, one of them's leaving the radical, boxing our final answer. And that is a 21. Yeah, okay. Looks like it was not 21. All right, excellent. So this is question 3. Let me skip ahead here. That's part B for you to try on your own. And this is question 4, rationalizing. So remember, if we have a radical in the denominator, this is like alarm bells going off. It's not okay. We can't have this. We need to change this. We need to do something. All right. Because remember, a radical is an irrational number, right? I think I mentioned in class, or I should have mentioned in class, I think I had like a crumble cookie example, right, with the denominator. If I didn't mention it, I'll mention it now, if I didn't mention it earlier. So if we've got like a crumble cookie box, if you will, and it holds 2 cookies, that's like our denominator. Our denominator is 2, and it can only hold 2 cookies. So you could have 0 cookies in the box. You could just be paying for the box. You could buy 1 cookie to plug in the box. You could buy 2, right? You could even buy 3, and then it's like they're overlapping. But the denominator is telling us, okay, this is how much it holds, how much it can hold. And then for irrational numbers, or even if we have a denominator of 0, especially that's where it's like undefined, really tricky, really trips you up, because denominator of 0 is undefined. It means this box can hold nothing, and yet there's something in it, and it's really confusing. Kind of similar idea with radicals. if you try to plug this in, I don't know if Desmos calculator will do it, but normal calculators will tell you like error. Oh, this one actually did work it out. This one's okay, but we don't want that specific number anyway. So sometimes it'll give you an error message when there's a radical in the denominator. I guess Desmos doesn't, but let me clear this out. So basically when our denominator is irrational, it gets kind of trippy because like square root of 6 is like 2.44. So remember, an irrational number is going on indefinitely and there's no pattern. So it's like for that crumble cookie, we've got this box that can contain this like weirdly specific amount, 2.449, and this is going on indefinitely, but there's no pattern. So it's really confusing. That's why we want to rationalize. We want to make it, clean it up a little bit. This is how we simplify. So anytime we see a radical in the denominator, wee alarm bells going off. We can't have this. We got to clean this up. How can we do this? We're going to use, remember, the multiplicative identity property, fancy word, multiplicative identity, which tells us we can multiply anything, any term by 1 many times we'd like, and we're not changing it. 512 times 1 is still 512. 10,003 times 1 is still 10,003, right? I'm not changing it. So this is what we call, remember, a special form. This is just a special form of 1, what we're going to plug in here. And what that is we're going to take rad 6 divided by rad 6. Why are we multiplying top and bottom? Because our goal is to get rid of this radical. Index is 2, so we're looking for a group of 2 of the same number. Right now it's 6, and it didn't have a partner. So we need to multiply it by rad 6 to give it a partner. How can we do this? Multiplicative identity. Basically, rad 6 divided by rad 6. If you don't believe me, check calculator. Rad 6 divided by rad 6 is 1, right? Any number divided by itself is 1. So I'm not changing the problem, just multiplying by 1. When we multiply fractions, we multiply straight across. We're going to go ahead and show those lines, multiplying straight across. Numerator will have 6 rad 6. Denominator, rad 6 times rad 6, that's 6 times 6. Just like on our last question, the index is 2, it's a square root, right? No index is given, plain old radical. Index is 2, it's a square root. We're looking for a group of 2 of the same number, and we can see, hurrah, we've got 2 of the same number. 1 cancels, the other is factored. Numerator is 6 rad 6. Denominator is now positive 6, all right? Because now the radical is no more, it is gone. And we can even simplify further for this one. Ooh, we can cancel those guys out because they're both just like coefficient in a plain number. They both weren't in the radical, so we can cancel. And this one will leave us with, let me put equal sign here, showing our steps, just square root 6. We can box. That's kind of fun. If you see one where it's like rad 6 divided by 6, if it's something like this, we can't cross them out. We can't cancel them because this is a radical. I know it's kind of weird. Radicals are strange. We can simplify them, and we also kind of treat them as variables, and we'll see that on the next, I believe is the next question. All right, but this one, in this case, rad 6 was the answer for question 4. Okay. You're trying that on your own. 3.3. Here we go. So this is where we're going to transition and now see radicals in a new light because there's so many different ways to do the same thing. So now we're going to look at radicals, kind of treating them as variables, right? Combining like terms, adding or subtracting radicals. So how do we do this? I guess I misspelled in simplest form. Okay. We're going to need to simplify because we need to see, can we combine these? Are these going to be like terms? Let's check. So rad 20 minus 2 rad 5. Rad 5 is prime. So nothing to do for that term. We can't simplify it. But rad 20 might be composite. Let's see. So 20, that would be 4 times 5, or if you didn't catch that, 2 times 10. We always circle our prime numbers to remind us, stop. We got to stop here. We can't keep going. Otherwise, we'll be here the rest of our lives. 2 times 1 and 1 times 1. and 2 times 1 and 2 times 1, right? We stop. All right, 10 is composite. We can keep going. That's going to be 2 times 5, and we're going to circle our prime numbers. All right, same as I think it was question number 3. Question number 3. We're going to list them out. 2, 2, and 5. Our index, once again, is 2. Index is 2. Looking for group of 2 the same number. Bam, there it is. 1 cancels, the other leaves the radical. So cleaning up rad 20 is going to leave us with 2 rad 5. So 2 rad 5. And it was 2 rad 5 minus 2 rad 5. Ooh, this was an interesting one. So remember, once we have them as the same radical, we're kind of treating this as like a variable. So if it's kind of confusing how we combine these like terms, side work, let's think about it with like a variable. So if this was like 2x minus 2x, maybe that is a little more helpful. And if we're still struggling, you can check in the calculator, just look at the coefficients. 2 minus 2, they should cancel and leave you with 0, with nada. So they cancel. This was a fun one. Our answer is actually 0. There's nothing left. They got canceled out. They're gone. All right, that was question number 5. And then I believe there is still a B for you to try. And then once you attempt, you can scroll down to check your answer, see if you got the right answer. All right, question 6. I think this is our last one. We'll double check. Question 6. Try this together. So now we're asked to multiply and then box our answer in simplest radical form. Be sure to show all working steps for full credit. Answer must contain a radical. I forgot to mention this earlier, but all of these say for full credit. This study guide is not graded. Your exam is graded. This is a mirror image to what your exam is going to look like. So this is your greatest tool to study, is going to be our study guide. All right, and how do we multiply? What do we do? We're going, just like we learned in class, we're going to start by multiplying the coefficients. We're going to take it nice and slow. We're going to multiply the coefficients. Multiply the coefficients first, and then we'll multiply the variables next. We're going to go nice and slow. All right, -2 times 3 is -6. Rad 10 times rad 20. So now we're multiply the radicals. Rad 10 times rad 20 is rad 200, right? We're just adding a 0 to 20. All right, we have multiplied, but now we still need to simplify. So we need to simplify. This one's kind of, it's like we're kind of going back a step. We already know this is 20 and 10, so we can just keep factoring for a factor tree. 20 is 4 and 5. Oh, celebrity sighting. That's a perfect square. But if you don't know what that means, we can keep going. 2 and 2. We circle those prime numbers. And 5 and 2. Okay. Simplifying, we're going to rewrite, whoa, let's try to make that a little straight. We're going to rewrite all of these prime factors in under one radical sign. So there are 1, 2, 3. If it's helpful, we can cross them out as we go. 1, 2, 3 2s and 2 5s. 1, 2 5s. All right. We still do have that -6 in front. There is an index of 2. So again, we're scanning, we're looking for a group of 2 of the same number. If the index was 3, we would be scanning and looking for a group of 3 of the same number, right? If it was 3, that's an example of a group of 3, right? But in this case, it was a plain old radical, group of 2. So I see 2 groups of 2 of the same number. 1 cancels out of those groups and 1 leaves. So outside the radical, we've still got that -6. And now we've got a 2 and a 5 also outside the radical, leaving us with rad 2 inside. We're going to need to figure out what that is. 6 times 2 is 12, times 5 is 60, and it was negative. So -60 square root 2 is our final answer for this one. All right. So when we're asked to multiply, we're going to go baby steps. Start with the coefficients. multiply the coefficients first, then multiply the radicals, and then just like what we did in question 3 or 4, can't remember which one, but factor tree. Hopefully by now we're really confident with factor tree at least. Factor tree, factor it out. We'll get negative 60 rad 2. Okay. This one's B, you're on your own. And then this is more examples. So if you've gone through the study guide, you're like, yeah, I think I still need some more help. This is all of our Khan Academy assigned topics. They're linked. So the first one hyperlinks you to the Khan Academy topic. And then the one just below it is my recording walking you through how to do that Khan Academy topic. So it's all on one slide. So while you're studying, you don't have to go back to 3.1, 3.2, 3.3, all those Khan Academy assignments. They're all here on the study guide. So this is like a one and done resource for you. If you guys have any questions, be sure to let me know. Canvas inbox preferred. Yeah, I hope this helps. Have a great day. Good luck.